In the demo part of the webinar, I will create a .NET application on OpenShift, and I will show you the source to image build strategy that we talked about earlier, and then we'll explore some of the deployment strategies, and finally we'll get a quick look at the dynamic provisioning of persistent volumes. So I'm going to go ahead and log into my web console, and then I'm going to create a new project. So I'm going to give my project a name, a display name, and go ahead and create it. Now that the project is created, OpenShift is going to present me with the list of runtimes. I'm going to select .NET. And then select the .NET Builder image. I'll give my app a name. And then I'm going to point it to the GitHub repo URL. So I'm going to copy that from the download link. I can set more parameters if I expand the advanced options. So we can configure an external route, or configure a webhook build trigger, which I'm going to show you in a few seconds. Or if I want to enable auto scaling, which means OpenShift will automatically scale up or down my application based on the CPU utilization. Or define the number of running instances for my application, or I can even limit the computing power and memory that my application can consume. For the purpose of the demo, I'm going to stick to the default options and go ahead and create it. And it's going to give me different ways to manage my application, so I can use the web console or the command line interface. And this is really cool. So you can create a webhook in your GitHub repo, and whenever you push a code change, the webhook is going to trigger your application to rebuild in OpenShift. I'm going to copy that URL, and I'm going to configure that in my GitHub repo. So I'm going to add the webhook. I'm going to paste the URL, change the content type to JSON, and disable SSL verification so I don't receive unwanted errors. So it makes the webhook pink, and that little green tick over there means that the webhook managed to contact the endpoint successfully. So while I was setting up the webhook, in the background the build process had already started. Remember that we're using the source to image build strategy, so S2I is going to clone my source code, compile, build, and create a new container image from that code, and then it will push it to the local OpenShift registry and deploy my application. So if I go back to the overview screen and go to the build logs, we'll see that the build is in progress. And that's in fact completed, and now it is building the layers of my container image. There we go. Switching back to the overview, now you'll see that OpenShift is starting up my pod. There we go. Perfect. So now we have one pod up and running. Let's recap what just happened here. The build process pushed the resulting image from the build to the local OpenShift registry, and this triggered a deployment, which in turn spinned up a new pod for my application. Now OpenShift also created a service for my application, and it even created an external route. So now we can see what our application looks like. There we go. Congratulations. So now we have a .NET application running on OpenShift on top of Microsoft Azure. Now I want to show you the build configuration for my application, so let's check that together. It's in fact a YAML file, and you can see the source for the build is a Git repository, and this is the URL. And the strategy, of course, is source. So that's the source to image, S2I. And similarly, we can check the deployment configuration. And we can see that, in fact, the strategy is rolling, which is the default for OpenShift, and that it is triggered based on image changes. What I want to do now is use the webhook we created to trigger a new build. So if I go to my Git repository and pick up any file, this one will do, and then make any changes to that file. Doesn't have to be something sophisticated, and then I'll just commit my change and head back to my build view. Find out, yes, indeed, 2 builds. My second build is running now, and it is triggered by the webhook we created for the change done by my user. You can also use the command line interface to interact with OpenShift. So I'm going to copy the link, and I'm going to log into OpenShift using the OC tool. And from there, I can also query the running builds with the OC get builds command. So the second build is the one running right now, and I can follow the build log as it progresses. There we go. Okay, so now the build is complete, and it should start building the layers for my container. There we go. There, so the build is now complete, and I can now query the pods that were created in my application. So you can see both pods for build 1 and 2 have completed their job. The pod from the previous deployment is still up and running, and that's normal because we're using the rolling deployment strategy, and the deployment pod is still running, and that last pod is our new pod, which is still being created. Let's now examine the service that was created for my application. So we can view more details if we use the describe command. There we go. And you'll note that the service has a label. So any pod that shares this same label will be associated with the service. You can also see the endpoints for the pods that are currently associated with this service. So if I go back to my project, there it is. And now scale up my application. So I now have 2 pods up and running. There we go. See how fast that happened? And then view my service again. So you'll see that it now has 2 endpoints, and that's because a new pod was created with the same label. So now my service knows that it can route any incoming request between those 2 pods. I can also query any object using its label. So now I'm going to get all the pods that have that label, .NET MVC. And it's going to display the 2 pods that we talked about. Next, let's see the replication controller. So the replication controller keeps monitoring the actual number of pods running to make sure that it equals the desired number of pods. Now if I use the ocgetrc command to query the replication controller for my application, there we go. You'll see that it lists the desired pods and the number of running pods. Now if I go ahead and scale my application even one more, so I have 3 pods running. Now what I want to do is kill one of those pods to show you the behavior of the RC. There. So I'm going to delete that last one. There, you'll see that almost immediately the replication controller spinned up a new pod in its place. And that is the self-healing property of OpenShift. Good. Now let's examine the difference in behavior between the rolling and the recreate deployment strategies. So I'm going to go to my deployment configuration file. And by default, OpenShift uses the rolling deployment strategy. I'm going to change that now to recreate. Save my file, and I'm going to deploy my application again. If we go back to the overview, there you'll see that OpenShift terminated all the old pods before it starts spinning up new pods one by one. There we go. Now if I go back to my deployment configuration file and I want to switch back the strategy to rolling deployment, and again save, deploy my application. There, so you'll see clearly the difference in behavior. So now OpenShift scaled up the new pod, so it spinned a pod from the new version before it terminated a pod from the old one, and it will keep doing this till I have an equal number of the new pods to that configured in the replication controller. Finally, I want to show you how smoothly claiming a persistent volume works between OpenShift and Azure. I'm going to create a new application, and this time I'm going to use one of the ready templates. So I'm going to choose the MySQL template with persistence. There it is. And so you'll see that in the parameters we have a parameter for 1 GB volume capacity. Now let's check the resources we have in the project. So I'm going to query the existing persistent volumes. And as you can see, there is no match for what my application needs. So let's create the application. And we can see that there is a deployment in progress for my new application. And now if I go ahead and check again the existing volumes. So if I query the existing persistent volumes, we'll find that a new one was dynamically created, and it is already bound to a persistent volume claim. And this is the persistent volume claim that was created by OpenShift for this deployment. And this brings us to the conclusion of the demo today. I hope this gave you some insights on some of the core concepts of Red Hat's OpenShift and how seamless the experience is on Microsoft Azure. So back to our slides, I just have two more. So those are some useful links you should check out. You can sign up for a free trial on Azure using the first link, and I definitely recommend that you check out the test drive for OpenShift on Microsoft Azure. And finally, you can also schedule a hands-on experience for you and your team at the Microsoft Technology Centers. And if you want more information, check any of those links, like the reference architecture for OpenShift on Azure. Thank you for your time, and I hope you enjoyed today's webinar as much as I have.